Here are the solutions to your homework on page 93. So we've got a cylinder. So we're going to use surface area equals 2 pi r squared plus 2 pi r h. So if all the way down the center of the circle is 4, that means that the radius has to be 2. And then the height of the cylinder is going to be 10. So we'll plug in 2 times 3.14 times 2 squared plus 2 times 3.14 times 2 times 10. We'll do our first set of exponents and multiplication, and that'll give us 25 and 1200ths. We'll do our second set of multiplication, and that'll give us 125 and 6/10ths, and we'll add those together for a total of 150 and 72 inches squared. Number 2, we're finding the surface area of a rectangular prism. So you need the formula 2LW plus 2LH plus 2WH. So your length today is 15, your width is 5, and your height is 10. So now you'll plug in 2 times 15 times 5 plus 2 times 15 times 10 plus 2 times 5 times 10. Well, you'll do your 3 sets of multiplication. 2 times 15 times 5 gives you 150 plus 2 times 15 times 10 gives you 300 plus 2 times 5 times 10 gives you 100. And when you sum, your total is 550 feet squared. Your next shape is a new shape this year. It is a triangular prism. So we need to use our formula. Surface area equals the height times the perimeter plus twice the area of the base, or the base shape. So the height of the entire thing is right here. That's going to be 12. Now, the next thing we need is the perimeter of the triangle. So as you can see, we know 8, and those two sides are going to be the same length there. So everything on the triangle is 8. So that's an equilateral triangle. So I'm going to do 8 times 3 for the 3 sides, which gives me 24. And then the area of the base, I have to use the area of a triangle formula. So 0.5 times the base of the triangle is 8, and the height of the triangle is 3. So B is 12. So now that I've got my 3 variable values, I'm going to plug those in. So surface area equals the height, which is 12, times the perimeter of the triangle, which is 24, plus twice the area of the triangle. We'll multiply, and then we will add for a total of 312 centimeters squared. At the bottom, we've got some word problems, so you have to read the word problems in order to decide what kind of shape you have. Because they don't have pictures, you also need to use the information. So it says a soup can has a diameter of 8 centimeters and a height of 10.5 centimeters. How much metal is needed to make the can? So that's going to be the surface of the can, and cans are cylinders. So we are going to use the surface area formula for a cylinder, 2 pi r squared plus 2 pi r h. Now they give us the diameter, so that tells me the radius has to be 4, or half of that, and then our h, of course, is 10.5. So we're going to plug in. And just like number 1, we're going to do our 2 sets of multiplication. So 2 times 3.14 times 4 to the second power is going to give me 148 hundredths. And then the second set of multiplication is going to give me 263 and 76 hundredths. And then when I sum, I will get a total of 364 and 24 hundredths centimeters squared. The next shape, it says Josh is wrapping a box that is 5.5 centimeters long, 14 7/8 centimeters wide, and 3 1/4 centimeters tall. How much wrapping paper will he need to cover the box? So that box is going to be the surface area formula for a rectangular prism, so 2LW plus 2LH plus 2WH. So the length, they told me, is 5.5. The width is 14 7/8. And then the height is 3 1/4. And you'll notice I used the decimal equivalent for all of those. And then you'll go ahead and plug those into your formula. 2 times the length times the width plus, I have to move over a little bit here. So now I'll do 2 times the length times the height. And then I'll do 2 times the width times the height. And then when we do our 3 sets of multiplication, you're going to get 163.625 plus 35.75 plus 96.6875. And when you sum all of those, you'll get approximately 296 1/10 feet squared. Our last problem says a cylindrical chemical tank is 12 feet high and has a diameter of 45 feet. How many cubic feet of liquid could the tank hold? So I want you to think about this for a second. It's cubic feet, and we are holding something. So this problem is actually volume. So in class, you'll remember I asked you to decide if you needed to find the surface area or the volume for number 3. So we are finding the volume, which we will practice next week.